This talk is Breaking Crypto Without Keys, Analyzing Data in Web Applications, in case you're in the wrong place. Quick intro about me. My name is Chris Ng. I'm the Director of Security Services for Veracode. We are a startup specializing in the application security space, and you'll probably hear more about us in the coming months. The past 6 years, I've been a consultant for AtStake and Symantec, specializing in penetration testing of web applications, networks, products, and whatnot. And prior to that, I was with the Department of Defense. A few quick assumptions that I'm going to make with this talk. The intended audience of this talk is primarily penetration testers, but it's going to also be useful to any of you people who are doing application development. It kind of helps you understand some of the things you might be doing wrong with regard to your crypto, and some of the things that a pen tester might be looking for. I'm assuming a basic understanding of cryptographic concepts at the very highest level. I'm no cryptographer myself. You really just need to understand kind of what a cipher is, difference between a block and a stream, things like that. But you don't have to understand any of the math. And I'm going to actually do a little quick refresher a few slides in. So quick agenda, we'll talk about the problem statement that we're trying to solve here, do the quick crypto refresher, go over some high-level analysis techniques for looking at data, and then the bulk of the presentation is really centered on the case studies. And these are real-world examples of penetration tests that we've done in which we've come across unknown data and how we kind of went about that process of figuring out what it was and then getting to the point of identification all the way up to a working exploit for the application. And if we have time, Q&A. This was originally a 75-minute talk, and it's a 60-minute block, so if I talk really fast, I apologize. I just want to get through as much of the material as possible. So the problem is this. What do you do when you're doing a web application pen test and you encounter unknown data? So that can be any number of things. It can be a cookie that gets issued by the application. It can be hidden fields or get post parameters that get sent back and forth between the browser and the application server. Sometimes these things are very transparent. They're ASCII, they're readable text. Other times they're just what we like to just call blobs of stuff. And it's not evident just looking at them with the human eye what they are. And what you really want to know is this something that I can even try to attack? Is this encrypted? Is this weakly encrypted? Is this just trivially encoded, and maybe it's something that I can easily reverse? Is it just a simple XOR with some static string? That's the main question we're trying to answer, so we can figure out to focus our efforts on this unknown blob, or to move on and find something else that's more appealing. The other question, how much do I really have to know about cryptography in order to exploit crypto implementation weaknesses? And I'll answer that one now, not very much. If you kind of know what some of the common weaknesses are, you really don't have to understand too much about crypto. It comes down more to pattern recognition and some basic high-level analysis techniques to recognize some of those flaws. So our goals are to understand those techniques, understand and recognize the characteristics that I referred to, and then apply those techniques to real-world pen tests. A lot of people just talk about theory, and I personally learn best by example, so that's why I've tried to design the talk in such a way that most of it, after I talk about the high-level concepts, most of it really is looking at the real data and breaking it down and showing you what we found, and hopefully that helps illustrate those concepts. Okay, the quick refresher. I'm going to breeze right through this. Two types of ciphers, block cipher and stream cipher. Block cipher operates on groups of bytes at a time, so you may encrypt 8 or 16 bytes at a time, given a certain algorithm. Block sizes can vary based on different algorithms, and block ciphers usually have different modes of operation for encrypting messages that are longer than the basic block size. So for example, if you have a 128-byte message, you encrypt it in 8-byte chunks, but there are different methods that you can use to put those blocks together. And we'll talk about one of the very weak modes that we're going to be looking to exploit. example ciphers that are block ciphers that you probably all recognize. A stream cipher is going to operate on the plain text one bit at a time. Usually what happens is there's a key stream that gets generated through the algorithm, and that's independent of the message data. And then what you do is you combine it with the plain text, usually with an XOR, to encrypt the data, or you XOR it with the ciphertext to decrypt. RC4 is the most common example of that. So the first block cipher mode that we're going to be looking at, and this is the weak one that we'll be talking about later, ECB mode, electronic codebook. In this mode, every block of plain text is encrypted independently of one another. So what this means is no matter where that piece of plain text falls in the overall message, it's going to encrypt to the same value, whether it's the first block, the last block, or anywhere in the middle. And you can see the kind of the diagram there. There's kind of no linking between the blocks. Each piece of plain text just goes into some encryption mechanism. The key goes in, and out comes ciphertext. The problem with this is that, first of all, structure in the plain text is reflected in the ciphertext. And I'll show you an example of that in a second. And the other weakness is that ciphertext blocks can be modified without detection. If I change something in the ciphertext in the overall message, that doesn't affect any of the rest of the data. So I have no idea that the message was really altered. Here's the textbook example of ECB mode, courtesy of Wikipedia. This is an image encrypted with ECB mode. And so you can see on the right side, a particular color, I guess, is always encrypted a certain way. So no matter where it is in the diagram, it always looks the same. So you can see how the patterns in the plain text data are still very evident. And we're going to carry that technique over to the web applications. The other block cipher mode that I want to talk about is CBC. This is a more secure mode in which, if you take a look at the diagram, what happens is each block of plain text is XORed with the previous ciphertext block before it's being encrypted. And the result of that is that each block of ciphertext is influenced by everything that came before it. So in doing that, if you alter one thing in the ciphertext, you've altered the rest of the message. So you can't, it's not just a simple codebook type operation like the previous mode. This is something that we're not really going to have many attacks against, but I just wanted to mention it. There are a couple other block cipher modes as well that are similar. They use chaining in different ways, but I'm not going to spend too much time on that. And finally, the stream cipher operation. Like I said before, this is usually a basic XOR operation. You take the algorithm, pass the key into the key scheduler, that generates a key stream, and then you combine it with the plain text to get the ciphertext. And the key stream is essentially infinite. You just keep generating it for however much plain text that you need. Okay, so our analysis techniques. This is something I want to put in here, but it didn't really fit anywhere else. So just in general, common methods of structuring data in tokens. When you're looking at structuring, putting a bunch of data into a single token, there are a number of different ways that it can be organized. And this is just kind of getting into the mind of the developer and thinking of, what is going to be the underlying construct of those cookies or those other tokens that we're looking to analyze. So sometimes it's fixed length data. If there are known lengths of data that are being put into the token, you might use 6 bytes, 6 bytes, 6 bytes. You might use variable length data with a separator character in between them. So like a pipe or some other sort of separator to kind of delineate fields. You may also use variable length data with length fields. So that's usually just the number of bytes and then the data, and then a number of bytes and then that number of data and so on. So keep that in mind as we go through the case studies. Common crypto mistakes in web applications, and this is what we're going to be targeting. The first one, proprietary or homegrown encryption algorithms. This one's probably self-explanatory. Don't try to make your own crypto up and be better than people who have been looking at stuff for years and years and years. People still think that they can do this successfully, and they usually can't. Insecure cipher mode is a big one. Like I mentioned before, using that weak ECB mode rather than CBC or OFB or any of the other more secure modes. Poor key selection, insufficient key length. These are all things that you hear about more often, I think. Insecure use, incorrect use of the crypto API, that comes down to a lot of understanding of what you're actually doing when you're calling some function to encrypt something. What is the default mode? Like how is this actually operating? Do you really understand what the crypto API is doing, or are you just using it and looking at the data that comes out and saying, okay, it's not readable, so it must be working. So here's where we're going to kind of start talking about the techniques that we can use to look at the unknown data. So we're looking at a web application, and we're looking at a cookie that's gotten issued by the app, and we're trying to figure out, what is this thing? What is this blob? So the first kind of thing you can do is to start looking at the length. Is the length, well, kind of the first step, is the length the same as a known hash algorithm? So is it 32 bytes? Okay, well, maybe it's going to be MD5 or something. Maybe it's a straight hash, maybe it's an HMAC. Just one thing to keep in mind, those common lengths of things that various algorithms spit out. Obviously, if it's a hash, one-way hash, we're not going to be doing too much with it. Is the length of the encrypted data a multiple of the common block size? So looking at the cookie, is it 8 bytes, 16 bytes, 80, or is it something that couldn't be a multiple, like 37 bytes or something? If it is a multiple of a common block size, then that might tell you that there might be a block cipher under here. Does running random-looking pieces of data through some form of entropy measurements show any sort of patterns? So one thing you can do here is just script up a little thing to grab a bunch of tokens repeatedly, and then run them through just basically a statistical analysis to see if there's an abundance of bytes at the low end or the high end, or theoretically. Something that's truly random should be completely shouldn't really show any peaks or valleys in terms of distribution of bytes. Some of the automated web app products do this, I think, with session IDs, but not so much with other pieces of data. Okay, another thing we can look for, are there any blocks of data that seem to repeat in the same encrypted message over multiple encrypted messages? So if we've determined that this is a block cipher because it's say 64 bytes, and we've broken it down into 8-byte chunks or 16-byte chunks, can you find any places where once you've broken it down on those block boundaries, the same block appears more than once? That's definitely a sign of ECB mode. There's some tricks you can play determining block size and trying to modify single blocks, swapping blocks between messages, and kind of just see what the application does, see how it reacts. Does it completely barf, or does just because it can't decrypt the thing at all, or does it still work, but you notice that your email address is now different in the profile page or something. Do multiple encrypted messages begin with the same block or series of blocks? A lot of times when you're using a secure mode such as CBC, you'll have kind of a top-heavy looking token where the first couple of blocks